Hello. Thank you, too kind. Right, where do you want me to? Is it okay here? Right, okay, cool. So, well, thank you all for coming today. My name is Ricardo Sueiras, so well said. I'm an evangelist at Amazon Web Services. What that means is that Amazon pay my wages, but I work for our customers, and I help them understand how to use our technology and share the stories that our customers are doing and doing with some of the stuff we make. So today's talk, I want to introduce reinforcement learning and share on the sort of theme of stories, the story of why we created a remote control autonomous vehicle, how it's helping people learn machine learning, okay? But first of all, I want to talk about something that kind of like is a kind of preamble to this talk, okay, which is for a long time there's been a section of scientists who've been trying to learn and understand how we as people learn new skills. Okay, so it could be, how do we, as a child, learn to ride a bike, or how do we learn to kick a ball, or how to improve how we kick balls or run faster. Okay, and the reason for that, okay, and the reason for wanting to know how this works is because if we can understand that, then maybe we can teach machines, okay, to do that and create machines that work and can do more human-like tasks. Okay, and so whilst we're not there yet, okay, what we have learned and what scientists have so far worked out is there is a sub-branch of machine learning called reinforcement learning, which is how we interact with our environment is showing promising results. So this talk really is more about the journey of reinforcement learning, and what I want you all hopefully to be able to know when you leave here is what reinforcement learning is, and hopefully explain it to your better half or someone else. Yeah. Following on from that, why did we actually do this? So at Amazon, we've got this philosophy of being customer obsessed, and one of the things that customers were telling us was that it's really hard to do machine learning. Can you make it easy for us? And in 2017, we created this little camera device called a deep lens. We released it, and lots of people created really interesting projects. There was one about 3 or 4 weeks ago on BBC. You might have seen it. One of our engineers, he had a cat with one of these kind of like intelligent cat flaps, and it kept bringing in prizes, and he didn't want to bring the cat to bring prizes in, so he created a machine learning model of a cat with a rat or a bird, and then he trained it so that if the cat had a thing in its mouth, the cat guard wouldn't open. Yeah, and that was on the BBC a few weeks ago. So we had some experience that releasing this toy, we call it a toy, actually had a really big impact on lots of people being interested in and then learning how to get started with machine learning. So last year, we have a big tech event in Vegas. We launched Deep Racer, okay? And what Deep Racer is a rather funky looking remote control car. It's an 18th scale car, and on top of that is built is put a battery and then a Raspberry Pi like computer. It's actually an Intel Atom based processor and a camera. Okay, and then we've got a whole bunch of Intel tech in there as well. OpenVINO, which is an inference engine, and RL Coach, which is a kind of an open source machine learning library and algorithm that Intel have developed specifically to do vision type workloads. So we created this, okay, and then we also created some supporting things such as a console, and I'm going to show you this. I'm going to show you this in action so you can see how easy this is to get started. And then we created a league, okay, because we wanted to try and build an element of competition, because we realized that it makes it more fun. And actually one of the very first talk I actually came here for was one of the guys was talking about gamification. And sorry, I do wonder a bit, so keep me in my spot. I came here and there was an interesting talk about gamification, and we're doing something similar. We've created a league. People are participating in physical events, but also in virtual online events. And the winners of these various races we're giving tickets to our big event in December in Vegas. But before I start, I want to talk a little bit about why I personally am interested. So this is me in 2014, or rather, this is what I created. I've got 2 kids. The kids are getting older. They're leaving behind a trail of devastation, i.e. lots of toys that are being discarded. So I thought, what I'll do is I'll get some of the old cars my son's got and see if I can make it drive around a very crude track, okay? So I was talking to one person here early on about my making. I'm a big maker, love taking toys, and I love adding tech to them and seeing what we can do with them. So that was my first journey into it, okay? And then shortly after, there was a community sprung out of the US that created they're called the Donkey Project, which is effectively a 1/18 scale remote control car with a Raspberry Pi, a camera, and some 3D printed parts, okay? And from that, a community formed. They had races. So this is a get together. They'd chalk out a track on the road. They'd get together, they'd race, they'd try to do things like see if they could do drifting competitions. But typically they were timed events. And so we thought this is a really great idea because it was really energizing the community. A lot of really interesting innovations were coming out of it, specifically better algorithms for detecting road features. So we ran our event in 2016. Sorry, 17, this is 17, okay, where we actually took that donkey car project and we had hundreds of people take part in that. So that was all good, it was all very exciting, and then we decided, right, let's build our own. And this is the genesis of Deep Racer. That's what's under the hood. I was going to try and bring my car in today, but because I came on the train, I just didn't want to risk bringing it in, because these things actually aren't available in the UK at the moment, and they're very hard, and I don't want to risk it. So underneath the covers, that's what's in it. And we've been running these physical races since November. We have these big events at summits. We have a challenge typically. The winner will go to Vegas, and we have these online ones. And I'm going to come back to this later on. Okay, you can see the car there. That's what it looks like when it's actually driving itself. So, reinforcement learning. So reinforcement learning, okay. So reinforcement learning, I'm going to sort of just take a sidestep into psychology for a minute, the psychology of operant conditioning, okay. Sounds like a mouthful, but this is a type of learning where we use behavior to change outcome, okay. And if we think of us as humans, okay, we typically have got 2 forms of conditioning, or reinforcement conditioning, okay. The first one is primary, or kind of like stuff we don't really learn, but we're born with, and actually we typically need, okay, to survive. So we need to breathe, we need to drink, we need to eat, we need to reproduce, or we'll die as a species, okay. So that kind of primary reinforcement, typically you don't learn, okay. But then we have the secondary reinforcement, okay, which is stuff that actually we end up wanting to do for whatever reason. So we are motivated as individuals. So Alex is obviously, he is motivated, rants at beige computers, right? That obviously came from somewhere, right? We have, someone who is motivated to tell beautiful stories through data. Yeah, we all have these things within ourselves, okay? And so this stuff we can typically learn, and is typically something that we can kind of become better at through stimuli. Now, I'm sure here we've got people who've got children and dogs. I've got my dog on my socks at all times. And with children and with dogs, we are practicing on a constant basis reinforcement learning. Okay, when my children were small and they were naughty, they go on the step. When my dog, when he's not doing what he doesn't want, what I don't want him to do, I don't give him a treat. When he's doing something good, I give him a treat. Okay, so they're responding. We're trying to train them to stimuli, but it's hard to do, right? Please. It's hard to do. So, if we could try and get to the primary reinforcement, okay, and try and do it from the beginning, it would be really easy. And so initially psychologists tried to see if we could influence that, and it's actually, the answer is that scientists have told us no, we can't do that. So we've got to figure out actually and work how we actually from a psychology perspective understand how people respond to these stimuli. And it's important because when I come back to this later on, we'll see this is a really important part of how we actually build reinforcement learning models. So what is reinforcement learning? So reinforcement learning is a model. So a model, just for kind of just level setting, a model is the output of some machine learning work, okay? So in the same way as when you're writing code, okay, you might compile it and you'll create an executable, which you can run on a computer. So a model is the output of some machine learning, okay? So it's a model that you deploy on something. So in our instance, it's a car, okay, that it's used to make actions or to determine what to do next. Within an environment, so a racetrack, for example, to achieve an objective. So in this instance, it's to go round a lap in the fastest time possible, okay? And all reinforcement learning problems, okay, have these basic constructs. So we work with NASA and we're doing the Mars rover with them. And so typically the model will be deployed on the Mars rover to navigate Mars within a hostile kind of crater-laden environment might be to collect soil samples, for example. So this is kind of like the background to all reinforcement learning problems. And for anyone here is familiar with machine learning at all, or a bit? Okay, so there's within machine learning and artificial intelligence, okay, machine learning is a subset of AI. AI is the human-like emulation by computers of, say, for example, vision, being able to detect something or hear something and understand something. And within that, we've got machine learning, and it's broken down into these three areas. Supervised is where you have data that's labeled. So you might have some financial transactions. Some you know are good, some you know are fraudulent. So we call that labeled data. You then create an algorithm, you train the data, and then the model that comes out of it allows you to detect whether a new transaction is either fraudulent or good, okay? But typically you have data that's actually labeled. You then have unsupervised learning where you've got no labeled data, you've got a ton of data, but you know that there might be some groupings of data. So, for example, I've got 100,000 legal documents, I've got some leases over here, I've got some wills over here, and machine learning and those algorithms will allow you to classify, those. Reinforcement learning doesn't have that, okay? It doesn't have the data in that same way, okay? It uses an agent to collect the data and then learn that way. So this is where kind of like it fits. And the reason why it's important, when I showed you the first example, my first example of trying to train a car to drive, that very first model in 2014, what I had to do is I had to drive the car around the track. And when I was doing that, it was taking pictures every sort of 5 seconds. And then I would have to look at the pictures and I would say, this is good behavior, this is bad behavior. So it was a supervised training set of images, which I would train and the model would get deployed and then it would go around. And that's okay if you've got controlled environments. But typically in the world we're in, they're too complex to model, okay? So you need something that can learn from the environment it's in, okay? And the other aspect of this, okay, which I've got a short video, is that if we use what we call behavioral cloning, the car will only ever be as good as me, okay? Because I'm driving the car, I'm generating the data, which means the model that gets created is only going to be as good as I am. Here is an example of OpenGym, which is another reinforcement learning platform. And it's been given the task, okay, to learn how to play Tetris. Now, it doesn't know anything about, breakout. Now, all it knows is it can move left, it can move right, okay, and a positive reward is that you get points, a negative reward is it dies. Now, going through this process, okay, over 50, 100, 200 times, it soon realizes, without having been told, that the most successful strategy is actually to work the edges and then basically rack up points really, really quickly, okay? And it's actually the same mechanism that was used by the OpenAI teams to create the AlphaGo tool that defeated the Go Grandmaster, and also the same one that was used to defeat the League of Legends champions, okay? Because they came up with moves that simply no one had ever even thought were possible. Okay, and that's the benefit of reinforcement learning. Because it's an agent that has time to explore every possibility, every permutation, it can come up with things that as humans we wouldn't rationally think of. Okay, so it's not just about playing games or cars though. Reinforcement learning has got lots of different use cases. We're working with sort of pharma companies. to reduce the number of compounds they need to look at for promising new drugs, because you can model drug reactions really, really easily, and therefore you can run reinforcement learning and simulations over hundreds of thousands, if hundreds of millions of times, okay, and narrow down the compounds you want to look at. In financial markets, okay, there are agents that, because the reward of a financial transaction are quite easy to model. You do a trade. Does it make money? That's a good reward. Do you lose money? It's a bad reward. So it's being used very heavily in financial organizations, and they typically perform much better than the existing software that's out there. And the other one that, because it came up earlier on, is A/B testing. Okay, now on the left-hand side is your typical A/B testing, okay, where you might have some options, and then you get to the end, and you decide which option you want to go with. With reinforcement learning, okay, what happens, okay, you still end up going to the same conclusion, but before you get there, you've got a larger percentage of your users are using the right, or what you think is the right option. So it's a way of doing A/B testing much more efficiently, and there's a company actually, I've got the Conductrix. They are leaders in that. They've got a brilliant blog post. If you're interested in A/B testing and using AI to do that, go to that blog post. Okay, but we've also got other companies. So this is a customer of ours who got really involved in Deep Racer. They're a kind of a knowledge company. This is the CTO, and as a result of kind of like playing around with these kind of toys, as some people call it, their internal developers have started developing new AI algorithms that are saving them lots of money. So I'm not going to talk about that one. What I'm going to talk about is actually how it works. Okay, how am I doing for time? 5 minutes, oh blimey, gosh. So how it works, we have an agent, okay? It operates within a racetrack, and at the beginning it doesn't know anything about it. All it knows is it can go forward, left, or right. And so what happens is every time it does something, okay, it gets a reward, okay? And then based on that reward, what happens is we use that data to create a model. So I'm going to show you how that actually works through some graphics. But before I do that, what is a reward? I talked about reward a few times, okay? With a kid, okay, they do something good, you give them a sticker chart. With a dog, you give them a treat. We have to create the behavior we want the reinforcement agent to use. But we have to be careful, okay, because there's a difference between what you want to incentivize versus the intention. Now, there's a very interesting story. It's called the Cobra Effect. Back in the day in India, one of the regions were trying to get rid of cobras, okay? So they said, we're going to give you 5 rupees for every cobra you bring in. So what happened, okay? People started breeding cobras. Okay, and they had more cobras, not less cobras, right? So the problem is that, and this is where it comes back to the kind of the psychology, right? Creating these reinforcement learning rewards is actually a lot more difficult because you have to factor in the intention versus the incentive. Okay, and here is a video of a robot that was asked to place a box as far away from its arm as possible. But what the model soon found out actually is just chucking it was the most effective strategy. Yeah. So again, you need to be very careful about how you incentivize. Within reinforcement learning, you also have this concept of explore versus exploit. As you create a model, okay, it starts knowing things. So my kids, as they got older, they realized that if they did certain things, they would get into trouble and they'd sit on the naughty step. Likewise, if you go to a restaurant, okay, and you've never been to a restaurant before, okay, you're in an explore phase. Okay, so you might go to an Indian restaurant and these might be the options. And you might try all of these, and then over many visits you might say, well, okay, Kara dosa is my favorite. Okay, but then you might go to a different restaurant, okay, and then you might think, I'll try Kara dosa because I know that's really good, but they might make the worst Kara dosa ever. And you've exploited something you know, but it's actually been a bad outcome, right? So this is actually how it works in reality, okay? When you're creating a reinforcement learning model, you have the concept of a reward function that rewards certain behavior. So in this instance, okay, the straight line gives the maximum reward. If you hit the barrier, you get out. Anything less gives you less than the maximum amount of reward. And what happens, okay, is as the agent starts exploring through thousands of iterations, explores all permutations and builds up a total, what we call cumulative reward. So it knows now that if I do X, I get a score of 4. If I do Y, I get a score of 44. So I'm going to carry on doing Y because I get more score. And what it looks like is something like this, okay? So as it starts exploring, it starts getting better, and eventually it figures out that the best, most rewarding behavior is to go straight. And this is what's happening when your agent is actually training. This is actually what it looks like in the console. On the left-hand side, when it's first starting, when it's exploring, and then when it's actually done a bit of exploring and it's exploiting, you can see now that the car is actually learning to drive itself pretty well. And then we have this concept of convergence, okay? The training typically takes hours, sometimes 1, 2, maybe 3, maybe even 8, 12, depending on how you configure it, okay? What we're aiming to do is get to what's called convergence. And convergence is basically where the difference between exploitation and exploration is minimized, okay? So you know that really you're not going to get any better. So I'm done. I'm going to just do a demo, if that's okay. So just to show you what this actually looks like. So I started one earlier on today. So this is what, this is actually a virtual representation of the car. But what I'm going to do is, so how we actually configure this, okay, so this is going back to the whole thing of how we're trying to make it easy for people. What we do is literally, we create a new what's called model, and then we select a racetrack that we want to effectively test this agent on. So this is the environment, and then we create what's called the action space. So this is the discrete action space, the rules effectively the agent can do when it's asked to interact with the environment. So we can configure things like, not that one, how many, whether we want 3 or 7 different ways to steer. We can change the maximum speed, the speed granularity, and then what that means is that the permutations of options that agent's got to interact with the environment is bigger. And if you've got more permutations, it means you're going to need longer time to train the model. Okay, and then you write your reward function. So this is the stick or the carrot. Okay, this is how you incentivize your agent, okay, to do the thing you want it to do. Okay, and again, we give some samples to get you started, and there's a community that I'm going to sort of give a shout out to in a minute that helps people understand how to write better ones so they can get faster times. And then literally, you then click on start, and that's it. And then, so I did one on the train coming here, and that's the one you've just seen. And if we look at the actual, that's what it's currently doing. Okay, so this is again, when it first started, this thing was bumping all over the place, and now it's actually doing a pretty reasonable job in how long has this been running? It's been running for 3 hours, nearly 4 hours. So in 4 hours of training, we built a reinforcement agent that can pretty effectively drive itself around the track. And that is that. My last slide. If you're interested and wanted to know more, we have a meetup next Thursday, I think it is, at the Amazon HQ in London. So we have a community that is run by champions of the Deep Racer League. So we have, I mentioned we had a league, and we've got people who have won these. They've built and run a community. So we're going to have a racetrack there. We're going to have cars, and I'm going to be running a session to teach people in more depth how to do this. If you're interested in coming, then pop along. It's a free event. We've got beer and pizza and all that kind of stuff. So with that, I shall open up to questions.